Hello.
Hello, can you hear me? Can you hear me?
Yes, sir, we are.
Yes. Great.
Hi.
Hi.
Am I audible?
Yes, you are. You are. I'll increase the volume a little bit, but you're audible. Hi.
Welcome back everyone to the post-lunch session. Now we have an invited talk entitled Reinforcement Learning with Structured Actions and Policies by Professor Balaraman, Ravindran, of Indian Institute of Technology, Madras, and I would request Professor Hargav P. Bhattacharya of Indian Statistical Institute to please come on stage and chair the session. Thank you.
So, hello, good afternoon. So this is my pleasant duty to introduce the speaker of this session, Professor Balaraman Ravindran. So he is currently a professor of computer science and engineering at IIT Madras, and as well as Mindtree faculty fellow. Additionally, he chairs the Robert Bosch Center for Artificial Intelligence and Data Sciences and the Center for Reasonable AI at IIT Madras. So he got his master's degree from Indian Institute of Science, Bangalore, and PhD degree from University of Massachusetts, Amherst. So he is one of the leading authority in the area of machine learning, and he has decades of experience in this area, particularly focusing to reinforcement learning, geometric learning, and his area of interest also includes social network, data mining, and text analytics. So he's named as one of the authorities in machine learning, particularly in the area of reinforcement learning in India and abroad. And he has written many influential papers in this area, and has a lot of industrial collaboration. He's a fellow of the Indian National Academy of Engineering. So welcome, Ravi.
Thank you, sir. Can people hear me clearly?
Yes.
And are my slides visible?
Yes, slides are visible. Please go ahead.
Okay, great. Thanks. So good afternoon, everyone. I apologize for the slight delay. There was an unexpected accident on the road here, so I couldn't make it back in time. So I wanted to also announce that IIT Madras has started this new Department of Data Science and AI, and I just wanted to give a plug for that, and I'm going to be heading that as well. So let's quickly get into the topic of the talk, which is reinforcement learning with structured actions and policies. Right? And So I mean, just to set the context, people know what machine learning is. It's about learning inputs from data, learning functions from data, where you are given a set of examples based on which you are going to learn, right? So these examples tell you a priori what you should be giving as an output for a specific input, right? So it's like saying that, okay, if I give you this as an input, then you have to tell me. Is everything okay?
Just a minute.
Yeah.
Sir, you can.
I can proceed. Yeah. Okay. Thank you. So classically, machine learning, you can think of it as being given a set of instructions. Okay, if this is the input, then this has to be the output, and then you learn a function generalizing these instructions, right? But if you think about how you learn to, let's say, cycle, right? And you are not going to be learning this from just data. You're not going to be learning this from instructions. Somebody can't just tell you this is how you have to cycle, and you can't get on and generalize, right? So you basically try things out, and you make mistakes, and you learn from this kind of a trial and error process, where if you fall down, you get hurt and get some injuries, or if you're a kid and you're cycling well, somebody claps and says, "Hey, well done," and so on and so forth, right? So the crux of reinforcement learning is that you first try something, and you get an evaluation for what you try. So that's a good thing to do, or that's a bad thing to do. You don't get instructions like you get in supervised learning. So this is a crux that distinguishes reinforcement learning from supervised learning, right? And so the mathematical characterization of this kind of learning from evaluation and through trial and error, there's all the tools and techniques and so on and so forth put together constitutes the field of reinforcement learning. And it's a very natural mode of learning for humans because, or any kind of animal, right? Whether not just cycling, whether it's walking, talking. Sorry, there was a lot of feedback on my side. Did the people in the auditorium also hear it?
Yes, sir. You are audible.
Not my voice. I'm getting a lot of feedback when I'm speaking. Ah, that's better. Okay, thanks. Thank you. So it's a very natural mode of learning for humans and animals, even for us, even things like walking, talking, and all that, are through this kind of evaluation and not explicit instruction as to how things need to be done, right? And reinforcement learning has got a lot of attention recently because we know that reinforcement learning works, right? And it is not just in simple player cases like game playing, but also more complex control problems, and also things like protein folding, right? In fact, reinforcement learning has had significant impact now in all kinds of scientific disciplines. So I like this slide because the first one talks about mathematics, the second one talks about chemistry, third about physics, and then biology, and then finally this is about aerospace. Right? So RL has been very successful in a variety of disciplines. Right? So one of the primary drawbacks in some sense, right, is that most RL settings assume that these actions that you are performing, right, like your actions that you perform to control a cycle, or the actions you perform on a board, right, to play a game, they all come from either an unordered set, like joystick controls, or some north, south, east, west, where you don't worry about what the semantics of these are. You just think of these as core actions, right, or some kind of other fixed set of actions like pick, place, and grasp, right? Or they come from a real interval. So either they come from an unordered set of actions, right, or they come from some real interval like accelerations or joint torques or some XYZ coordinates of your target and so on and so forth. But they don't actually look at the structure that is often present in these action spaces, right? So many real world problems actually have this kind of a structure in the output space, and so they can be exploited effectively. I already gave an example of the cardinal direction, right? North, south, east, west, and in some sense, going north instead of going east, right, is a lesser of a error than going west instead of going east, right? So there is some notion of relations in the spatial structure in these kinds of actions, but typically RL methods have treated these as just cardinal. I mean, just like four different actions without any connections between them. Right? So the kind of structures that you see in action spaces are could be combinatorial, right? So there are multiple Boolean attributes that you have to select, and so the actions that are related depending on whatever attributes you select, right? And then the second thing is like relational structure. I already gave you an example of the spatial relations, like or there could be relations that are explicitly encoded as a graph, right? And like binary or even multivariate relations can be expressed in graphs. So the actions could themselves be, in some sense, connected. So I'll give you examples of both where the structure in the action space comes from the spatial location and then comes from the kind of a graph relations, right? In the later part of the talk, right? And the final kind of structure is what we call as repeated structure. It could be very simple repetition in terms of actions being repeated a number of times before you actually change your policy, right? Or it could be in terms of your solution is composed of multiple simpler problems, right? And then you decompose it into simpler problems, and they solve each of these, and then combine the policies together. And so this is some kind of a hierarchy. Or it could be just like a lot of things that you already have, right? Prior knowledge, and you're trying to construct solutions by reusing pieces of the prior knowledge and so on and so forth. So there are many ways in which you have structure in the policy that is repeated throughout the solution. This and across problem settings as well. Right, so I'll talk about a couple of examples from that. Right, so I'm not going to go into nitty-gritty details of each of these. And if you are, I mean, I have all the papers in the last slide, or if you want to reach out to me later to know more details, please feel free. The first thing, very simple thing is about repeated action. Just to give you motivation, I take a simple game setting. And as you can see here, this is a game in which the optimal policy, right, the final solution consists of something like going, up 29 times in a row, or going down 28 times in a row. That's a very simple setting, but where we see this, but also more complex settings. So this is a multi criteria optimization problem that you have to solve for playing this game, right? And even here you see that optimal policies consist of the same action repeated many times, and this is typical in many complex control scenarios, right? So it's not like you don't take just one action, but you actually take the same action several times before you cause a significant displacement in your state, and then you think about changing the action, right? In fact, there is a version of dynamic programming called transition point dynamic programming, which is completely predicated on this constancy of policies over large regions in the space. Anyway, that's an aside. So the basic aim of what we set out to build was not just have a kind of a fixed repetition, right? It's not like every time you take an action, you do it 3 times or 4 times. We wanted to learn it in a dynamic fashion, right? So now we are deciding not just what the action to take, but also how long you want to execute it, right? And now this essentially allows you to build policies that change less rapidly, right? And also build more complex, longer horizon decisions because you're making fewer decision changes, right? And also allows you to have a setup for what we call as temporal abstraction in the policy space. And there is a lot of relation to some behavioral psychology literature also, where people talk about this notion of chunking. Even though chunking is a slightly different notion, but it's related. Right? So what we did was we came up with a framework. I'm not getting into the details of the framework, but which is very lightweight extension to the optimization setting that you have. So you could take most most reinforcement learning algorithms that have an explicit loss for the policy, right? That has an explicit representation for the policy that you're going to solve, that you're going to learn, and use that and learn the duration as well, not just the policy action, but also the duration. So we give this like a meta framework, and people have tried it with multiple base algorithms and have shown that it improves the performance. So here is some of the results that we have, and this is across a large family of games called the Atari learning environment. And you can see that at the top end, we get thousands of or hundreds and thousands of percentage improvement, right? And this is 91,822. So in some cases, you are able to learn very efficiently. That is probably because this additional optimization term we add acts as a very good regularizer in certain settings. And of course, you can always create environments where this kind of thing would fail. But at least our approach learns that repetition is not a good thing to do, and then comes down to just taking each action only once. So it is able to adjust for those errors. So in the interest of time, I won't discuss this graphically, except to say that this one tells you how useful is repetition in a particular game. And the more pink a bar is, right? The more pink a bar is, the more useful is repetition. And the more white the bar is, then repetitions are not that useful, right? So that's basically the way to read this. And you can see that across multiple instances, we find that repetition is useful. And not only that, this is also able to learn different repetition factors in different parts of the state space. Okay? So the second class of approaches I want to talk about is what I call as action representation learning. And people are all familiar with representation learning, right? So if you have been looking at, it's not that representation learning is something that is possible only through deep neural networks. People have been looking at representation learning for much longer. But with deep learning, it has become a lot more popular topic to talk about, right? Representation learning. So whether it is language or images or whatever it is, we talk about representation learning. But it is almost always on the input side of things, right? So we are always learning a representation of the input side. Now we are talking about the output side, right? Where the actions that I am going to take are going to have some structure. Therefore, I can do representation learning on the action side also. I can do representation learning on the output side, right? So the motivation for this was originally That most RL methods have problems with a large set of actions, but many problems have a large set of actions. But when the action set is very large, they typically have some kind of relations also. It is not like you have like a million unique actions which have no, well, you could have a million unique actions, but it's not that they are completely independent of each other. So some examples, places where these kind of large set of actions occur is in like, say, recommender systems, right? So where you have lots of items to recommend, but then these items would be potentially grouped by some kind of category or product type and so on and so forth. So you could have some amount of generalization happening across the various items that you have to recommend. Or it could be some, I mean, one of the examples that we have been exploring recently is in trying to generate molecules, right? A feasible molecule. And at every point of step, you start with the molecule structure that you have and you want to move towards your target. And there are hundreds of different ways in which you can go forward, right? And each one of these is a potential action that you could take, right? And it turns out that I don't have to consider these as independent actions because they have all kinds of relationship between them. I can learn these in some kind of a latent representation space. Right? So the idea here is then, so instead of taking actions from your large set, you could actually choose these actions in the latent space, right? And then once the agent, while it is actually controlling a system, right, it will pick an action in the latent space, and they have to have a way of transforming it into a real action. Right? So apart from these large set of actions, you also have other places where this action representation learning is very useful. So one setting is where you have a varying number of actions, right? So not all actions are available at all times, right? And only a certain number of alternatives are presented to you at a given instance, right? And you have to choose among them, right? So the next time you come to the state, you might get presented a slightly different set of alternatives and so on and so forth. Or you might be generalizing from one instance of a problem to another instance, and these actions could change from one instance to the other, right? In such a case, learning on an explicit set of action, even though at every instance you might have only a small set of actions, since these actions could change over time, you would really like to learn in this kind of a latent space so that generalization can happen over the action. Right? And the other setting, which again we will have an example of, is where the actions are a priori unknown. So it's not like I can't tell you that I have 15 actions and I'm learning from those when you start the learning, because as you keep learning, right, more and more quote unquote actions are discovered. So for example, suppose I'm using reinforcement learning to select which beneficiary to direct a particular benefit to, right? So at this point of time, okay, which are the 5 beneficiaries I will call and call them for something, right? So the beneficiaries could continuously be enrolled into the system. They could be dropped off because they kind of just no shows and so on and so forth, right? So I don't a priori when I start the problem, I wouldn't know how many beneficiaries I'm going to have and what kind of characteristics these beneficiaries will have and so on. So I would have to continuously keep updating my action space. And again, having a latent representation for the actions will make it easy to generalize. And other instances, when we're talking about this kind of hierarchies or sub-problems and so on and so forth, then you could keep learning more and more solutions along the way, right? So you want to actually learn a representation of these sub-problem solutions so that you could generalize across these as well. So you don't have to continuously keep changing the number of actions you have because you learned a new sub-problem, learn to solve a new sub-problem. Right? So there are multiple ways in which this action representation learning can be used, and a lot of work is being done in this space. But one of the earliest papers was this one, learning action representations for RL, which appeared in ICML 2019, led by a group from UMass. And I'm using this because they have a very nice visualization of what this latent space looks like, right? And so I also feel okay to talk about it because the first author, Yash Chandak, was a student of mine, so I kind of feel like vicarious ownership of the work. So here is a simple case where there is a robot and that has multiple controllers that could take it in one of these directions pointed here. Right? I think there are 12 controllers here, right? And each one of them takes you a little bit in the direction that is pointed to, right? And so you have each of these controllers can be independently turned on or off. So there are total of 2 power n, suppose there are n controllers, you have 2 power n actions, right? And so what you see here is the end result, right? So the displacement that you have in the Cartesian space of some combination of these controllers coming on. So each dot here corresponds to one combination from this 2 power n, right? So this is 2 power 12. So you have 2 power 12 dots here, and each one corresponds to a specific combination of the controllers coming on, right? And they have been color coded so that you can see what happens when I learn the embedding. So what they did was they actually used this some kind of an embedding, like an autoencoder based embedding technique that translated these 2 power n actions into a two-dimensional space, right? So this figure that you see with the E1, E2 on the axis is not the XY coordinates, right? So it's not the spatial coordinates, it's some latent space. And the color coding now transfers here. You can see that. So you can see all the greens, move you in one direction, all the reds move you in another direction, and so on, so forth, right? So you can see that the color coding more or less transfers here. So things that move you in a certain direction and a certain depth, right, get projected together in this 2D space. So now you can actually generalize over this actions that are learned, as opposed to treating each action individually. So in which case you would have to learn 2 power 12 action values. Now you can learn directly in this latent space. So that's basically what they show. And of course, this figure tells you that with the action representation learning, you're able to generalize much better than without, right? So that's basically the idea behind this. So I just wanted to use that as an example, right? So the first piece of work I'm going to talk a little bit more about is on influence maximization in unknown social networks and learning policies for effective graph sampling, right? So the point I'm going to talk about is how do you use reinforcement learning for doing graph sampling, right? And this is joint work with Harsha, Priyesh, Brian, and Milind Tamri. And Harsha and Priyesh were master students with me, and Brian was a PhD student at Harvard and now a faculty at CMU, and Milind, of course, all of you know, is at Harvard and Google. So the influence maximization problem is a well-known problem, and in fact, ironically, one of the earlier talks I gave at ISI was about some work that we did on the basic influence maximization problem. But now I'm not going to talk about that. I'm going to use the influence maximization setting as a platform. So the problem is I'm given a graph G, right? And I have to select some subset K from this set of vertices V. And if I initiate a diffusion process from these nodes K, right? Assuming that there's a well-defined diffusion process, what is the number of nodes that get influenced, right? The total number of nodes that to which this information flow or diffusion process that I start from K reaches, right? I want to pick a K of a specific budget, right? So that the propagation is maximized. So there's a lot of standard work that people have used for solving this problem. But the motivating application for us was the following, right? So there were a lot of sudden spike in HIV infection among the homeless youth in Los Angeles, right? So, and Milind and this group are actually working with the public health folks to try to see how they can use AI to address this issue. And what they wanted to do was, pick some nodes as a peer leader, right, from the network of homeless youth, right? So figure out who are the people who would be good leaders who can go out and influence the other people in the ecosystem to stop using drugs or so on and so forth, or whatever is the cause for the HIV problem. But the biggest issue here is that they didn't know the network of students, right? Network of homeless people, right? So they are not on some social media waiting to be marketed to, right? What they had to do was go out and start, with the paper and pencil and ask people, okay, who are your friends, who are you connected to, and how often you meet them, and those kinds of questions, with some kind of a survey-based questionnaire, right, to discover the graph itself. And then once the graph is discovered, you could just go run influence maximization on it, right? So just like using the classical. So that's basically what they were trying to do. So here is how we set this problem up, right? So here is the full graph that you don't know, right? So all the nodes, the white, the red, and the gray nodes, all and the black edges between them constitute the full graph, which you don't know, right? So here is some intermediate problem of the intermediate stage, right, of the decision making. So the nodes in color and the edges between them are what you have discovered so far. So the gray nodes are the ones whom you have already administered the questionnaire to, right? and they have told you about their friends, which are the red nodes. The red nodes, you haven't asked them questions yet. Right? Now, what is your problem? You have to decide which of these red nodes do I go and ask a question next as to who their neighbors are. That's what I hope. So the set of actions for me is the set of nodes that can be queried. Right. So now these set of nodes are going to change from step to step, right? And I don't know the whole graph, so I don't know what node is going to come to me. And if I learn a policy only on this querying policy only on this graph, right, where I'm going to specialize it to the nodes of this graph alone, I will not be able to generalize it to a new situation. Therefore, I can't just take the ID of the nodes. First, I don't know the ID of the nodes. I don't know how many more nodes are going to be discovered. And even if I had all of that for this one graph, I will not be able to generalize. Right? So we need to think of some other way by which we can pick actions from these nodes. Right? And so we'll come to that now. So basically the thing progresses as follows. So I have the state, which is the colored nodes is what I have already known. So that's the state of my agent. And the RL agent selects a node B from here, say maybe it selects this node B, and that's my action. And now I have to go query that node. So I'll query that node, and that node gives me these neighbors. There's maroon nodes or the nodes that have been discovered newly. And now if I have budget, then I go back and update the graph so that my new state looks like this, right? So now this node has become gray, and these nodes have been added. These are the red nodes that were delivered. Okay, and if I am done with the query budget, I'll declare that this is the graph. Whatever the shaded nodes I have here, I'll declare that this is the graph that I have discovered. I'll run influence maximization on this, and then go ahead and finally solve the problem. So that's how we set it up. So the challenge, like I pointed out, is to figure out how you are going to represent these actions, right? So for that, what we did, I think I have about 10 minutes left. Is that correct? Anyone? Yeah.
Mike. So 1 minute, sir.
Yeah.
Sir, can mic. Sir, can mic.
Sorry, I just asked how much time I have left. Based on that, I'll go fast or slow down. 10 minutes? Oh man. That much confusion. 10 minutes?
Sir,
Do I have 10
minutes,
minutes?
sir.
Huh? 15
Sir,
minutes?
am I audible, sir? Yes, sir.
Yes, now
15
you are
minutes,
audible.
sir.
15 minutes. Great, thank you.
Yes, thank you, sir.
Sorry, but yeah. So what we did was that we had to learn the actions and we have to learn a representation for the states also. I'll not get, again, like I said, I'm keeping the talk light. So what we did was we had a neural network with two pathways, right? So the top pathway was doing state representation learning, and the bottom pathway was doing action representation learning. If we really need to know, we used a GCN, a set of GCNs with diff pooling to learn the state representation, which is basically the graph that we have discovered so far. And we use some kind of node to wake deep walk architecture for learning the node representation. I mean, I have to say these were all empirically chosen. There is no strong reason to choose one over the other here. And we chose the one that actually worked best for us for this particular setting that we have. Right? And so quick summary of the results that we were getting. So if you look at the homeless network, so we had like a percentage increase over the baseline of about 20%, right? You can see that anywhere between 10 to 35, 36% is the improvement that we had over the best known solution so far. These are all over the state of the art for the network discovery using this kind of not using reinforcement learning. The state of the art was using some set of tested heuristics from the social network literature. Okay. So that's basically where that was, right? So going on to the second example, since I have a little bit more time, the second example we wanted to talk about is the one on using reinforcement learning for allocation and patrolling in signaling games. Right? Again, this is a work with a team from Millen's group. So Arvind was a research fellow with me. Elizabeth was a PhD student who is now a faculty at Michigan Ann Arbor. Harsha and Keval were master students with me. Right. So the idea here was to come up with a mechanism for helping forest rangers and other wildlife protection folks to combat poaching. Right. So that is basically the idea. And earlier some work had been done by Millen's group, especially Liz, in modeling these kinds of problems using what are called Stackelberg security games, where they are looking at the strategic interactions between law enforcement agencies and their opponents. Right? And these were modeled as repeated games. And the idea is that some finite set of targets, which is the wildlife, and there are very, very limited resources in terms of how many people and what kind of resources you can employ. And with that, you have to make sure that you're doing good, you're defending the targets to the best extent, right? And so what we wanted to do was we wanted to focus on slightly more realistic scenarios than what had been done in the literature earlier, because the classical way of solving this allocation and patrolling problem was to use some kind of either LP or mixed integer linear program. And to make sure that those were being solved tractably, a lot of simplifying assumptions were being made. And so we wanted to keep the number of simplifying assumptions as few as possible. And we set up doing a reinforcement learning strategy. So it's came up with a model that combines allocation, patrolling, communication, real-time changes in settings, and also a lot of uncertainty in the way you sense the world. Right? It's not like you're always 100% sure or your actions always 100% succeed. Right? So we came up with a method that uses multi-agent RL and action representation learning and all kinds of competitive optimization algorithms that we tried, baselines that we tried. So I'm not going to get into the other aspects of it. I'll just talk about the action representation learning part in a little bit, right? So very quickly, the setting is the following. So you have a forest area, and the color here indicates the density of the targets, so the number of animals, right? So the density is 1 all the way to 0, and you can see that there are certain patches which are more dense and certain patches which are less dense. And this kind of model scenarios, like where there is a river flowing through the forest area, like that. So you have the defenders, which are the drones and the ranger. Right, drones are more agile; they can move around, while the rangers also move around, but they are slower than the drones. The drones typically are doing some kind of regular patrolling strategy, while the rangers are moving much slower. And there are adversaries, in which case these are poachers, right? Okay, this shows up as blue, but the adversaries are actually in red here in the picture. Right? And then there are two decisions that you could do. You can choose to move in a specific direction. So the drones are choosing to move in these directions as indicated. The adversary is choosing to move in a specific direction, and the rangers are moving in a specific direction. And the second control that is available to it is a communication control. So the drones can communicate to the rangers, saying that, hey, I have spotted a adversary at this location. And they could also warn, right? So they could also warn the adversary, the poacher, saying that, hey, I have spotted you. In which case, adversary just runs away without doing any more robberies. But whatever they have done so far, they will assume that they keep it. So that's not the most ideal setting. We really want the adversary to be captured by the ranger so that they are arrested. But and sometimes to limit damage, if the ranger is very far away, the drone might choose to warn the adversary and make him run away. Right? So the first stage is typically modeled as a zero-sum game, and the second stage is usually modeled as a partially observable stochastic game. Right? And the game ends when the adversary escapes, right? That is, he flees the space, or the adversary is caught, or if the preset time limit is exceeded. That means adversary has been happily robbing you or poaching, killing animals up to that point, And that after that point, you don't, your trial ends anyway. It could be like the end of the day, or the next day starts. So like I said, there is already there are detection uncertainties and communication uncertainties that are there. So we divided this into two stages. There is an allocation stage and then the patrolling stage, and these stages interact. Right? So in the allocation stage, we assume that there is a utility maximizing adversary, somebody who knows where the ranger and the where the animals are, right? And also you're putting these adversary in a location where they can cause the maximum damage. How they move about is determined by the patrolling stage, which again has a full knowledge of the animal density and also has knowledge of where the defender agents were located initially. So this makes it a lot more powerful adversary and makes it challenging to learn a policy against them. Right? I just talk about the allocation stage where we had to use action representation learning. Remember, I was talking about combinatorial actions. I also was talking about spatial relationships that we can extract, exploit. So that's basically what we are doing here. Right. So we have n cells in the grid. So I'll break up the forest area into n cells, and there are m agents, right? So it's a certain number of drones and certain number of agents. We are not rangers. We are not differentiating that. Let's say we have m defender agents. So there are n choose m times m factorial possible allocation strategies for the defender, right? And likewise, the adversary has a certain number of ways that the adversary can respond, right? So what we do is first we do this allocation, right? And then we allow this setting to evolve to see how well the adversaries do with this kind of an initial allocation. And we look at the total reward that the agent gets, right? That the defenders get while defending the targets from this initial allocation, right? And use that as the payoff for the allocation that we did. So this is the one action that we take, and this is going to receive a payoff, and that payoff is determined by the outcome of the patrolling stage. That's why I said the two stages are interlinked. But the challenge with this, right, there are so many possible allocations that I have to consider, because I can't consider them as independently putting a ranger and a drone into each cell. I have to look at the allocation as a whole, right? And because of that, I have a very, very large number of actions. Right? And with these large number of actions, I'm not able to learn anything useful using the more standard RL algorithms. So we basically used a representation learning, right? So what is the representation learning approach? We randomly, generated 100,000 different allocations here. Randomly generated 100,000 different allocations like this, right? So locations for the ranger, the drone, and also the tracker. Right? Then what we did, we trained a neural network autoencoder, right, to learn an embedding from these allocations. This is basically from the 100,000 allocations, we learned they are embedding in some latent space, right? I think it is a 256 dimension latent space. Then what we did was we performed, now we will have 100,000 points in that space, right? So we perform k-means clustering over these embeddings and choose a small number of actions. I think we chose about 1,000 actions from 100,000. We chose about 1,000 clusters. And the centers of these clusters were the actions that the agent can now choose. So the first stage here, right? So instead of choosing from n choose m into m factorial, which is we had a 15 by 15 grid and 5 agents, 5 to 7 agents is what we tried. So you can see that it's a huge number. Instead of that, we just had 100,000 allocation, which we reduced to 100 actions. 100 or 1,000 actions, I don't remember. And then the agent only learned from these 1,000 actions. They basically learned which of these 1,000 actions is the right one to do, right, for a particular animal density and so on and so forth. So that's basically what we did. And the second stage, the patrolling stage, we used a standard multi-agent RL algorithm. We didn't do anything fancy here. Yeah, we did have to do some amount of state representation learning, but action representation we didn't have to worry about, right? So that's basically everything put together, and you can see that COMBEST TPO, which is what we did. does learn much more efficiently than the other classical languages. And also not just learns efficiently, it learns some very interesting strategies, right? So this is the animal density map, and this is the poacher density map, right? This is all the states that were attacked by the poacher, and you can see that the poacher was limited to a very small corner of the space, while with the other competing methods that we looked at, upgrade P was the best out there, and so you can see that no, guards was the best out there. And you can see that we are doing way better than that. And also multiple kinds of emergent behaviors come in. So I'm not going to talk about these. But a lot of very interesting emergent strategies come when you are having multiple rangers, drones, and also multiple poachers. So we did a lot of work. I already today I spoke about nodes in graphs, which appeared in NAMAS 2020. Then we talked about combinatorial spatial coordinates. They just now finished there, NAMAS 2021. We looked at learning molecules as actions. That paper is under review. And then, in fact, we learned about, we have actually done some work on action representations for entire policies, not just for actions. Right? So representation learning for policies as opposed to action. And that work was from a couple of years back in EC1. So very quickly, I'll take the next 3 minutes or so to run through our basic philosophy of combining policy. So the idea here is that, so you have this kind of a multi-level decision making. So you have what a master policy or a higher level policy, which would learn to choose various sub-policies, right? So it could be a gating function, it could be a mixing function, however you want that master policy to operate. It is going to mix these lower level policies, and which will then in turn pick an action. Right? So if it's a gating function, it is like a more classical hierarchical reinforcement learning setting, where you have sub policies and you pick one at a time, and then you kind of solve the large problem by using a combination or sequences of these sub policies. And if you have this as more of a mixing function, it comes up with more interesting things like transfer learning, continual learning kind of setting. Doesn't quite fit the hierarchical RL setting, but more in the general combining policy setting, right? So we have done quite a bit of work in the combining policy space, where we talked about reusing parts of policies, which we have several papers that have happened. Then we're talking about reusing complete policies, right? And also combining not just policies, but solution methods. So not talking about combining symbolic logic and planning. We have had a lot of old work, but more recently, we had a paper in ICAPS 2020. Also looking at combining classical planning and RL. So we have one paper in the review, and we have something from L4DC earlier this year. So there's a lot of things that can be done, right? So quickly, an acknowledgement. So all of these are my students. Most of them are master students and a couple of PhD students in there. And some of my collaborators, like I already called out. So Harsha was a PhD student in UT Dallas and now works at IBM. And Mitesh is a colleague at IIT Madras. Sriram, Milind, Prasad are collaborators from elsewhere, and Bharat is from the industry. Also like to thank all these people for supporting research. So before I end, right, I have wanted to point out something. Here is a blue agent that has learned to actually nicely score goals, right? You can see that it's doing fairly well, right? Now what happens, just watch what happens when the goalie there in red just starts, lying down and starts wiggling his hand. This blue guy gets all confused. He's not even trying to go to the ball, right? It's just that tap dancing its way and going somewhere else. So what had happened was the training was done in a very different environment, right? And during testing, the goalie decided to behave in an adversarial way, pushing it to parts of the space it has not seen before, right? So reinforcement, when people are talking a lot about adversarial robustness and attacks and so on and so forth on classification and even on ranking system. So adversarial attacks on RL is still a very nascent area. Right? So there's a lot of excitement, right, in the reinforcement learning community. And I think I started publishing somewhere around here, right, when RL was in this infancy in RL. But now this is only till 2017. I think the scale will have to change if I want to talk about how it is in 2023. It's very, very exciting. But there are still many fundamental questions that need to be addressed in reinforcement learning. So not just structured actions, but things like robustness, transparency, fairness. I mean, what even its fairness in the RL context, and also human allied operation, etc., etc. So not just RL. So I think these are questions that we need to ask all of AI, and that is something that we do in our new Center for Responsible AI. We talk about responsible use of AI in multiple sectors. So for me, the research goal has been for a while to be more omnivorous in the way we learn, right? Not just learn from simple RL signals, but also learn from any kind of other input, side information, other things we have. It's more closer to how humans learn. There is a collection of the papers that I mentioned in the talk. So happy to take questions.
Yeah, Ravi, can you hear me?
Yes, sir.
Okay, so let us thank the speaker for demystifying reinforcement learning and elaborating a lot of examples. So now the floor is open for questions. Any question, please? You have any question? Okay,
So, I am Pavitra. One question I have is that, with the new all the policy gradient and other approaches coming up.
Sorry, I heard the policy gradient and I couldn't hear after that.
So, from those point of view, can we tell that which one is the best? Because they are the representation and all these gets more and more difficult. So is it moving towards a direction where we don't need to do all this and it automatically learns and comes up with the formulation? Is it
So
possible?
most of the policy gradient methods are great when you're learning with, continuous actions, right? Many of the policy gradient methods also struggle when you try to do discrete actions. In fact, it was there on one of the slides. I didn't point it out for the poaching problem that we looked at. We tried, policy gradient methods first without doing any action representation learning. They didn't scale at all, right? So when you're talking about very large number of discrete actions, even policy gradient methods don't scale, right? Because they don't do explicit representation learning on the output side at all. None of these methods do representation learning on the output side. They do only on the input side. So even if for continuous actions, policy gradient methods have become pretty robust nowadays. But for large discrete actions, which is mostly what I was talking about, it's still the challenge getting it to work even with policy gradient methods. If you want me to give you one recommendation to try first, then I would say SAC. Soft actor critic is an algorithm that would be my go-to policy gradient algorithm. But even that would have trouble with large actions.
So that's the sequence in which you should try.
Yeah.
Thank you. Thank you.
Any other question? Ravi, may I ask you one question?
Yeah, please.
So you talked about this combinatorial SDPO and two-dimensional drone and adversary thing. So in the area of VLSI also you have similar problem, like you have the problem is very similar to maze routing, and there are many source and destinations and they collide each other. The problem is to optimize it so that the number of intersection is minimized. So I have heard that a lot of people are working, applying reinforcement learning to solve this automation problem. What is your opinion about
Oh, yeah, there's a lot of work. Kamakoti and I have done some work on FPGA place and route and all that. And it is a very good domain to try RL on because it's very controlled. There is a very clear objective that you can look at, and it's very easy to try multiple solutions, and you can do exploratory actions and all that because we have got very good estimate for wire length and intersection things, and all the technology mapping can be simulated, everything with very, very high fidelity. So it's a fantastic domain to try RL on. And the Google guys have done some really amazing, mind-blowing stuff in the last couple of years in that space. So, it's great domain to work on.
Yes, so very good applications there. So, and the last question, so you talked about this repetitive actions and so, right?
Yep.
What about the stock market prediction?
Stock markets are not stationary. So
No, no.
anything that is non-stationary, we are going to have trouble with. Having said that, there have been people who have been trying using what is called recurrent reinforcement learning, where you use recurrent neural networks for the policy representation and all that. And they have tried it on stock market price predictions and so on and so forth. Since I don't understand stock markets very well, I don't even try to invest. So I've stayed away from the domain, but I know that people have actually worked on it. And there have been some good success stories using recurrent neural networks and RL for stock market prediction. But for me, it's always, I'm very wary about it because I think there are just too many externalities which we don't model typically when we're trying to do stock market prediction. And that might make the problem pretty weak.
Too many uncertainties, yes.
Yeah.
Okay, Ravi, thank you very much. We missed you here, it would have been much better if you
So sorry, sir, I couldn't make it. It's just too many.
usually, as a token of appreciation, from the conference organization, we usually give a memento, maybe the organization made it.
Sure. Thank you, sir. Thank you.
Thank you, Professor Ravindran, for the talk. And thank you, Professor Bhattacharya, for conducting the session. I'll request Professor Utpal Gorai of Indian Statistical Institute to please felicitate Professor Bhattacharya with a memento. Now we have an industrial session, and I'll request Professor Utpal Gorai of Indian Statistical Institute to please chair the session for us.
Recording cloud to Zoom by cloud.
Very good afternoon, everyone. So now we have a session on basically industry session. So this session we have 3 speakers, mostly from our industry sponsors. So one is Flytex, and second one is Indian Bank, and third one is Ideas. Basically, that is the Technology Innovation Hub in ISI, sponsored by TST. Now, so in this session, we'll start with Jobin. Jobin Wilson is from Flytex. They will speak for around 15 minutes, and then so most of the talks are very much application oriented. So you might have some questions, and you may. We'll give you 5 minutes for introduction. So let's start with Jobin, please. You have your talk loaded here. Okay. So Jobin is in Flytex, and he is the in the field of AIML. He is a chief scientist here, and currently he is doing PhD in which year, Jobin? In IIT Delhi. About to finish. Oh, so he has submitted his PhD. He is basically looking after the R&D activity in Flytex, and his area of research is very interesting. So it's definitely in AI, but he is working on recommender systems, and also the last question what Ravindran wanted to say, that non-stationary learning. So Jobin has expertise in non-stationary learning, but you understand that this is not a full-fledged research talk, right? So probably, but if you have interest, you can interact with Javed. So with these few words, I request Javed to start.
Thank you for the kind words. So good afternoon all. My talk today. Good afternoon all. My talk today is titled Generative AI from Words to Words. So I think generative AI requires no introduction. It has become a household term thanks to ChatGPT. So basically, generative AI is able to generate new artifacts based on data patterns that it has learned from a lot of data. And the new artifacts that it generates could be natural language conversations, it could be code, like generating programming artifacts, or maybe test cases using copilots, maybe generating images, or maybe even generating audio. So all of these has a common recipe. So if you look at it, at the core, there is a powerful generative model. There is some kind of self-supervised training mechanism. And finally, there is a task-specific fine-tuning that kind of takes these foundation models and tune them to perform specific tasks at very high precision. And challenges also span most of these applications, primarily making this Gen AI trustworthy in terms of safe responses, how to take care of privacy, ethics, and intellectual property. So I think the story of text and image generation is pretty popular. We all know about it. Chatbots solving customer issues, or maybe marketers generating multimedia content like images or email content for promotions, or maybe software engineers writing code, or even business users asking AI to analyze a draft contract and surface any risks. These are all very familiar use cases that we have heard about. But apparently, the power doesn't stop with just words or maybe images. So we have this diverse domain where maybe even before ChatGPT became an overnight hit, these kind of applications were around. For instance, generative design in the physical world, for instance, designing buildings, maybe automobile parts, subject to some kind of constraints on cost and reliability, and maybe some kind of new innovative designs. The same is true even in digital space. For instance, if a telecom company wants to design a plan which consists of maybe hardware like an iPhone bundled with free minutes, maybe some free data, OTT apps, etc. So how could one come up with some product bundle structure like that and price it optimally so that it's likely to be a hit in the market? And there are applications where market simulation or even digital twins are involved. Market simulation being the case of estimating the purchases and market success of products, and maybe digital twins is about making a digital replica of a physical thing. Even that physical thing could be a whole airport to plan the logistics and activities out there. And even consumer-facing applications are coming up in a large form, where let's say from a small description of your preference of a living space, AI could generate floor plans or exterior designs. So these are traditionally not like textual or purely visual applications. They are actually into much more beyond that. Now getting into a conceptual view, why does generative AI work? So discriminative classifiers have been already being studied extensively. If we take a high dimensional image, for instance, and feed it to a classifier, it can generate a label like a cat, for instance. And let's say we reverse this and we ask by giving a label cat, an image could be generated out. So if we combine this discriminative view and generative view, and let's say think about an architecture where an encoder takes in some kind of text, image, audio, or a design, in fact, and generate a latent representation, which a decoder could further take and generate maybe text, which could be conversations, or maybe a design, or audio, or image. So this becomes like a powerful architecture where you could kind of mix and match many encoders and decoders to create generative AI for so many different tasks. And at the core, we know that the representation learned from large amount of data pertaining to a domain will allow a model to kind of model the nuances in its representation. Then now, how does the LLM story fit here? So the previous architecture holds true for LLM as well. So at the core, let's say it's a next word predictor. We could say the cat sat on the and asked the model to fill it. It's likely to come up with an answer like match instead of cactus because the patterns are like that. So there is this pre-training step where an encoder decoder gets trained based on masked words where text is randomly masked and the decoder has to kind of generate it. So a strong representation learning happens in the pre-training to give us a foundation model, and foundation model gets fine-tuned for specific downstream tasks like instruction following, task summarization, maybe a sentiment analysis, etc., and followed by reinforcement learning with human feedback to orient it based on human preferences, safety, and toxicity handling, etc. And one common recipe that we see is that all of this has been around, it's a scale that has brought in the magic. So we could see the parameter size growth, and it's being rumored that it's around 1.7 trillion parameters for GPT-4. We don't really know the architecture, but it seems size is growing and growing. Now, how do you adapt generative AI to proprietary domains where you have proprietary data and you are interested in solving specific use cases? For instance, you want to engage with your customers by automatically designing campaigns that are relevant to those customers. Maybe use the right words, right offers, right channel, etc. Or you could be even doing things like sentiment analysis for restaurants on a food delivery platform to find out which aspects of that restaurant's deliveries what the customers are talking about. So there could be three possible ways in which one could approach this. One is to go to API vendors like OpenAI or Hugging Face or Microsoft who sells APIs, LLM APIs, which could be used to build custom applications. The other could be to build domains augmented foundation models by fine-tuning open source models like Mistral or Falcon on your proprietary data. And the extreme case could be even building custom foundation models all the way up for your specific domain. But these comes with trade-offs. Of course, training a custom foundation model is going to be a very costly affair. Only very few people can afford it. Whereas domain augmented foundation model is all about fine-tuning. There are computationally efficient ways today to do it. So these kind of approaches gives you different types of trade-offs. If you are in terms of maybe privacy and control to data, maybe the cost for training, maybe how the AI performance improves on your particular domain task, etc. For instance, if you are relying on a third-party API, it's just used for inference. So even if your downstream task performance gives you feedback on how your AI did, you will not be able to incorporate it back into your AI because it's just an inference. Whereas if you were doing a domain augmented foundation model for it, you could actually do a fine tuning for your task specific reward and make it even better. And implementation speed is a key concern in the industry. So if you were to deliver things fast, going with the open API, publicly available API and paying per use might be a good way to get started. And then moving on to the more advanced methods. Now, all this is good. Then what is the problem? So I think in the previous talks also we kind of hinted on adversarial examples which even existed before this ChatGPT jailbreaking stories coming up in the newspapers. So adversarial examples can fool image recognition systems or voice recognition systems, making it think that's our horses, or maybe a seamless, a harmless command could be like a very dangerous command for a home automation system to open your door. So, and even the prime number detection example that many people quote, that ChatGPT gets it wrong sometimes. Maybe the answer is correct, maybe the reasoning is wrong. Of course, ChatGPT said textual model. It's not supposed to solve math problems per se. So here also the final answer is correct, but actually the factors that it detected is not really correct. So the limited understanding of the underlying reality is what we have seen here. It could even go to other extremes like hallucination. So here we asked the model about which paper introduced this particular algorithm, learn++.nsc, which is a famous concept with non-stationary learning ensemble algorithm. So it kind of imagines a paper title, which looks very realistic to a paper in that domain, and even associates it with real authors who really never wrote that this paper. This paper itself never existed. And then you ask it, is it really, are you really sure? It confidently hallucinates again and associates it to a different paper, which is a real paper by these authors, but it doesn't talk about this particular algorithm. So the underlying thing is that AI doesn't actually reason, but it imitates reasoning based on patterns that it learned from lots and lots of data. So the key considerations that one should have in mind when you take generative AI and adopt it to your domain, particularly it spans data aspects, hallucination, and model drift. We will touch upon these briefly. LLMs are trained on public data on internet, which contains all sorts of biases and inconsistencies. And let's say you asked an LLM to write a Python function which detects if a customer is a loyal customer, and confidently writes a code like this, which looks at the profession, and apparently engineers, doctors, or teachers are kind of loyal, maybe, and maybe others are not. That's what the code is trying to put together. But it's really society's own bias in the data that is getting reflected here. And hallucination, I think we saw the paper example was a case of sentence contradiction or a factual contradiction, where it kind of contradicts its own previous outputs. There could be even prompt contradiction where it does exactly the opposite of what you asked it to do, like write a positive review, it writes a negative review. So sometimes inconsistent or nonsensical responses also coming up. So why does this hallucination happen? Because LLMs are just constructing a plausible text completion, and facts are actually stored as network weights. It's not really a knowledge management system per se. Couples the language abilities with the knowledge management, which is probably not a good idea. And that's why people have talked about retrieval augmented generation and loading facts dynamically to the context of the LLMs. So the mitigation strategy also involves things like active strategy, where you kind of reduce hyperparameter values for like temperature to be set low to reduce stochasticity, or getting inspiration from multi-shot learning or few-shot learning, conveying the intent of your prompt with multiple examples for in-context learning, or even going to the extreme of retrieval augmented generation, where you have a retrieval component which loads facts dynamically based on a query and asks the LLM to reason based on the facts loaded. So in short, these techniques, including decoupling knowledge management from LLM and loading it using sophisticated techniques, including knowledge graphs, for instance, is an approach that is emerging. And knowledge graphs would also give an additional benefit that, let's say, it can load the facts and maybe do a fact checking by itself based on maybe if the response is really factual or not. Now, model drift is an important thing that I think since we touched upon the issue of non-stationarity, apparently the behavior of large language models are rumored to change over time. So this Stanford group published a paper a couple of months back about how ChatGPT's behavior changed over time in a matter of 3 months. So they kind of analyzed ChatGPT API's behavior based on 8 tasks which they outlined in this paper. For instance, prime number check was one of the tasks. And apparently they found that in March, GPT-4 had an 84% accuracy there in that task, and it fell to 51% in June. Possibly the model architectures changed, the training data changed, fine-tuning changed, the environment changes. So the changes to the model actually makes its behavior change over time. And there are also other tasks which are interesting in this paper. I think some of us might have seen this paper. It's an interesting paper. So mitigating drift is an important issue, but it's not specific to generative AI. Any AI deployed in production has to actually monitor how good is it doing over time, and if there is any change in the performance, it needs to flag the corrective actions. For instance, you built an AI which relied on this prime number check, assuming a hypothetical task, and behind the scene, the API changed, and your downstream application will break without even you realizing it. So that's why this approach of having application-specific tasks stored in the repository and using a monitoring layer to kind of fire these tasks against the API to detect if there's a significant increase in the error rate, which might hint about a drift. So I think people are looking at it from different angles. The AutoML community is trying to build self-maintaining models, for instance, which not only generate a optimal model, but deploy it, monitor it, and correct it over time. And the other option is, of course, to have fine-tuned models that are specific to your enterprise, so that way you have more control on how the model changes. To conclude, the key takeaway points is that the power of generative AI extends far beyond textual or visual domains, and specialized domain-specific AI holds a lot of promise with some of the applications that we discussed. Industry use cases like generative campaign design or product design or market simulation could be an interesting thing to look at. And GenAI apparently doesn't actually reason, but it has still demonstrated the power of imitating reasoning, which is very powerful because the data and patterns that it has learned these reasoning steps are at the internet scale, which gives a lot of power to the models. And building trustworthy Gen AI is definitely an important thing which requires specialized techniques. For instance, how do we handle risks associated with hallucination? How do we deal with drifts? How do we deal with inherent biases and inconsistencies in the data, etc. And these require special attention and techniques that the community has to come up with. With that, I stop. Thank you for the attention. Happy to take your questions.
Thank you, Kevin. So, okay, we can have a couple of questions from you. Yeah, please. So, Professor Ravindran from IIT Kharagpur.
Yeah, very nice talk. One question I have is that usually the design is an iterative process. I mean, you don't have a single shot design. You define it. So is it possible to have a API kind of thing which is support this iterative process instead of giving one single design?
Yeah, so today this prompt engineering apparently is a step which allows the user to iterate over the designs of the prompts themselves of the API. So it's just like a developer trying out a couple of approaches. The prompt designer could try it and then use the best optimal prompt now, as of now, against the API. But the risk today is that if that optimal thing changes with time, the way the API provider changes it. So that's why maybe tomorrow's providers might even add a drift monitoring to this scheme, which maybe the consumer could subscribe to. It says, yeah, this is my task. If it changes, alert me.
Yeah, that would be that.
And even AutoML could be one more solution. Let's say we got an alert, if an AutoML can automatically try out engineered versions of the prompt and select the best new prompt.
Okay, among the
like an optimization.
But the LLM algorithm doesn't have a role to, once it gets the feedback, to decide. It is not possible.
Yeah, today the problem is the language capability and the knowledge capability is kind of mixed up into one. So generally, that's why many providers say this is a snapshot as of so and so date of the model. But maybe it will evolve to a scheme where maybe knowledge and reasoning could kind of coexist towards dynamically loading.
Because normally when you see a search engine like Google, when you use a search engine, we usually keep on changing our queries over a session and to get better and better results.
Yes.
So maybe something like that would be more.
Yeah.
But
Yeah.
yeah, there is no theory to support that right now. Thank you very much.
Thank you. Yeah, one more question. Yeah.
Hello. I wanted to ask, what is the challenges regarding the reasoning aspect of ChatGPT or any other generative model? Like, what we need to do in order to improve the reasoning aspect so that we can get the correct answer or one answer that we need.
Yeah, so that's a good question. So how do we improve reasoning of LLMs? So the short answer is that LLMs by themselves don't reason. So this new frameworks like LangChain, for instance, or maybe orchestrators that are coming in, basically will invoke different subcomponents. For instance, let's say you want to fetch some additional data from the internet. You could have a plugin that will fetch that data and put it into the LLM's context. So that way LLM can reason better. Or maybe this prime check example. You don't want to do prime check as an expert completion. You will probably ask to invoke a Python interpreter and say, write a function that checks the prime check using some algorithm, run this on that data and return the result. So that way, the field is probably emerging in a way where LLMs are used for their strengths and there are orchestrators that kind of
Basically, a feedback mechanism.
yeah, some way of connecting different components like Lego bricks to kind of achieve a use case.
And recently, Sam Altman came with this rumor that he is the star algorithm.
Mhm.
So, is that something that reflects in that website?
I really don't have much idea about it, but generally people tend to prefer like LLMs became an overnight sensation because maybe years of lab work has already happened, but nobody could get the real outcome. The end user couldn't get the outcome, right? So similarly, this rumored thing might, if it's a disruption which kind of does things like that, then definitely yes. But still, I think it's unclear at this point.
Thank you.
So let's thank Jubin again for this coverage of from word to world and use of LLMs in industry. Thank you, Jubin.
Thank you.
There is one more question.
Oh, Jubin, please come here. So
And request
small.
Professor Balaraman to please felicitate Mr. Vinci with the language.
So on behalf of the organization, again, thank you for the kind sponsorship. Thank you for the opportunity to speak. Convey our thanks to your company. Definitely. Thank you, Jimmy. Our next speaker is Mr. Satish Kumar. So he is representing Indian Bank. So Mr. Satish is in charge of basically he is the chief manager, zonal chief manager for the Bharat zone. And we are really thankful to him because yesterday late evening we discussed that we need a session on banking operations, especially analytics and other things. So he is the right person to give us a lot of use cases where they are using a lot of analytics tools. So he is in charge of digital marketing and also the retail sections. And he will give us different use cases of the analytics tools and the associated problems. So with these few words, I request Mr. Satish to come on the stage. Thank you, Satish, for coming here. And it was really, you didn't have much time for this, but we are really thankful to you.
Good evening, one and all. As Sir told, I am from Indian Bank, Zonal Office, Barasar. First of all, I want to thank you all, especially the organizers, the Institute of Training 2023, for giving me such an opportunity to interact with officials, personnels from such a prestigious as well as premier institution, Indian Statistical Institute. That itself, I feel very much delightful as well as excited also to interact with you. See, banking has changed a lot, especially as per the Indian country. More than 70% of the business is being done by the PSU banking space. PSU banking space in the sense, these banks are owned by the government of India. More than 70% of the business comes from government owned banks only. And Indian Bank is one such bank whereby government owns close to 80% of the stake. And in the year 2020, Indian Bank, which is Chennai based bank, Chennai Tamil Nadu based bank, has taken over Allahabad Bank as per government guidelines. And now we have got more outlets spread across India. That is the biggest geography. That gives us the biggest opportunity for this data access. Clientele, what they do, and how we will be able to give them a superior customer experience. Nowadays, the requirement of clientele has changed a lot, which has given us the more opportunities also. How to go about it? What is the requirements? Whether do we cater to them properly? Suppose if a dissatisfied customer is there, definitely he will move out of the bank. He will search for some other institution where his requirements is being met. So, taking into account all these things, Indian Bank has embarked on a digital transformation phase, and I take care. We are end users. Here I am in Barasat. My office is in Barasat. We are end users. Our corporate level decisions are being taken at Chennai. Suppose Tata Consultancy Services is our software provider for our bank. And similarly, there are many more vendors who does this software-related works for us. And the percolation of information from our head office, it goes through our zonal office to all other outlets. Outlets in the sense, I call it as branches, ATM machines, BNA machines, or whatever it is. Let me go to the topic. See, why data analytics in banking? Data is very much essential for an organization to grow. Data is the raw material for us. Suppose a basic thing which a customer wants by walking into a branch premises, opening of an account. For that, we will be giving application forms. He will be filling it up, and thereafter we will be able to scan certain application forms, photographs, his signature, or whatever we want. And then all those information are captured into the system, which we call it as core banking platform. All of our branches are integrated into this core banking platform. So thereafter the account gets opened. So okay, after this, what we have to give? Account is opened. Some amount he will be depositing, say 500 rupees or 1000 rupees or whatever is the minimum stipulated. After that, what we will be giving? The first basic technology product that we give them is the ATM cards. What does this ATM card does? Instead of from the next time onwards, instead of coming to branch, a customer can withdraw the money through the ATM cards themselves. That is the first thing, a basic transaction, basic level transaction I am telling. Then, now we are in the digital era. Everybody has access to recent technology items like UPI and so many, much more are there. With that ATM card, if a customer is purchasing some merchandise, suppose a shirt material or a grocery item, he wants to make payment at the merchandise. he can activate his UPI platforms also through his ATM card. That is a self-service channel which is available to him. He can activate in a cell phone. In a cell phone, we have enabled this mobile banking. Basically, we have got this digital channels as mobile banking and internet banking. In mobile banking, he can activate his UPI platforms also, and the payment will be done to the vendor. So without coming to the branch, he will be able to use his amount which is lying in the account. Now, let's go on further. Suppose he needs some amount. I will throw a little more light on this also. Over 70% of the executives in banks worldwide say customer centricity is important to them. This is in line with what I have told you, the very first thing. Customer, what is his requirements? How we are going to cater to his requirements? That is the centric thing which we will be able to cater to. This is according to CAP Germany and EFMS research, only 37% of the customers believe that banks understand their needs and preferences adequately. See, this is the need which we want to cater to. This is the need which we want to cater to. We want to address. That is the reason we have embarked on all this kind of digital transformation phase. Less than half of banks analyze customers' external data such as social media activities and online behavior. See, I hope everybody must be into this social media. Now, what happens is that suppose if you want some information, you will be searching in the social media, say whether it is Twitter or Google or whatever it is. The next time onwards, after day 1 or day 2, a similar information which you have searched in the Google or whatever it is, the similar type of information gets populated in your social media also. Suppose our bank next week it is going to sell a sovereign gold bond. If you just search that in the Google, for the next time onwards in Facebook or Twitter, whatever it is, similar information related to sovereign gold bond appears on the social media. So that one also we are exploring. Our bank, Indian Bank, it is very strong in social media platforms also. Next, only 28% analyze customers' share of wallet, one of the key measures of the bank's relationship with its customer. Here, again, basic things we have got now ATM, UPA, and then say example sovereign gold bond. Suppose if a person wants to buy a car, where he will go? He has got access to banking. He has got account with our bank. Just if he access the mobile banking platform, he can apply for a car loan. Now, in our bank, in Indian Bank, I would say, in just 5 to 10 minutes time, he will be able to access this mobile banking platform and get a loan amount. So that is the digital journeys which Indian Bank has been adopting. So there comes that point. Only 29% analyze customer share of wallet. Key measures of the bank's relationship with its customers. Now this point also we are addressing. That is why we are moving more into this digital area. Only 30% hands-on experience with the live big data implementation. So majority are still focusing on pilots and experiments. Now, challenges faced with banks. Unstructured data, customer analytics, single view of customer, governance, fraud identification. This last part which I want to stress more is that fraud identification. See, we have been advertising at many places. Just because the clientele that we deal with is from different geographies, different social strata of the society. Of course, we give Android mobile applications, internet banking is everywhere it has got penetration. However, while a call comes for the same customer saying that I am the branch manager calling from Indian Bank, you would have received a OTP in your mobile. It is as part of other verification I am calling you. You please share the OTP. We are advertising through various medias that nowhere the client or anybody, they should not share the OTP, even if a branch manager or branch official in this case or somebody is asking. They should, once that is given, that's what that cell phone itself, it will be cloned and the money will be instantly transferred to various channels. He will lose the money. So that is the area which is a serious threat as far as this technology banking is concerned, which our bank is addressing in a very efficient way. Here, banking analytics, how banks can benefit from advanced analytics in banking. A 360-degree view of the customer. What exact? There may be many requirements. First, I told about this account opening, debit card, and then internet banking, mobile banking, and also loan. Now, what else can we do? What else we will be able to service them? Any reward points, credit cards, so many things are there. Credit cards are there, and now demat trading account, demat account, everything can also be done. So we will have to have a 360-degree perspective of the customer requirements. All this digital transformation helps us in such a way. The source systems, if you look at, this is the main part of our architecture. One is CBS, that is a basic platform upon which the full entire database is built. And then we have got net banking and mobile banking. These are all the channels which we offer to the customers to access the banking channel. Similarly, we have got our treasury department, which is based in Mumbai. And then this debit cards, credit cards, these are all our products to access this banking channel sitting at one place, or at the customer's convenience, they can use this. These are all the. And one more thing which I want to tell you is, look at the channels. The below one you see channels, SMS, email, intranet, web portal, and dashboards. The SMS, email, completely that mobile phone and email is where ultimately which we are insisting upon. OTP will be sent through SMS as well as email. So that is very important. That should be registered. You can change the internet banking. While you access internet banking, the passwords and all, you yourself can set it. So that is the kind of facility which we offer to our customers. So this is all about our bank's analytics division. Whatever information which we are receiving from our corporate office, we are making it available to our end users who are none other than our clientele base. They will be able to access it easily all across our platforms, especially digital channels, where they will be able to get maximum benefit out of our bank's products. Ultimately, we want to offer them a superior customer experience so that we can retain them. They will not be going out of our bank for any kind of service requirements. Ultimately, all things we want to become a one-stop shop for all kind of financial services in the banking industry, because banking and financial industries is the maximum usage of this technology. We are relying more on this technology for providing a better customer service. Thank you all. Thank you.
Thank you, Mr. Satish. Nice coverage of the banking activities. So, if you have a couple of queries and or any point of interaction with Mr. Satish. Person from IIT.
Very illuminating talk. So one question I have, when you say a single view of the customer, so is it, do you mean that it is only the view regarding the interaction with the bank and not the views with respect to say other, should not say bank with this branch, or is it an integrated core banking, means activity across the branch, or everything is?
Yeah. See, suppose basically, if a customer comes to the branch, we do the account opening work.
Okay.
Whereas in this digital transformation phase, what we expect is it should be a 360-degree view of the clientele requirements. What exactly do they require other than opening an account? Why do they have come to us for opening an account? Whether they are interested in some loan, they would have already looked through our website or something like that. Some records might have been there. They would have looked at home loan, how much is the rate of interest. Rate of interest would have been very less. So they would have come to the branch for basic things which we require is opening of an account. After that, we will have to inquire with them, sir, you have opened an account with us. What exactly do you require more? You are interested in some demat account already, or you are interested in home loans? Yes. If it is home loans, okay, sir, please have a word with our loan department. There it will be like, oh, what is your requirement? Where are you employed? A similar question. This is one scenario which I am telling you. Similarly, something else may be there. Suppose today we must be aware that many IPOs are taking place. A customer might be interested in applying for an IPO, for which an account is required basic thing.
Yeah.
Through net banking, he can apply. Yes, sir. I want to. Since because I'm staying nearby, my house is nearby, and mine is a work from home. I have got some time to spend here for this IPO facility. I have come over here to access this IPO facility. Through internet banking, you can apply. That is the requirement. So there again, it takes a different form of requirement. So I mean to say many requirements. We have to look at it at a 360-degree view.
And one single customer can have multiple requirements also.
Exactly. Exactly.
Multiple.
That is what I told about this wallet share.
Okay.
Wallet share. There what the bank generally proposes is that we want to have at least minimum 5 products, 5 financial products of our bank for a single customer.
Thank you.
Thank you. So, any more queries? Yeah, please.
Hello. Yeah. So my question is, you mentioned something about social media activity of your users. So one application I can see is that based on their social media activity or purchase history, you can have offers on credit card or something. Other than that, what are the uses of like tracking their social media or something?
See, when it comes to investment, let me tell you with the same similar example which I have covered already. See, suppose investment, when it comes to investment, we have got in our bank deposit products. Similarly, our bank distributes mutual funds also. Similarly, our bank is distributor, being Government of India owner, we distribute sovereign gold bonds. This sovereign gold bond. Suppose next week I come to know that next week we will be issuing the next series of sovereign gold bond. Shortly we will be issuing. Suppose now the customer we want to distribute. The customer is not finding time to come to branch to purchase it. Now what we do is we will make a publicity through Twitter, social media, all those platforms. There we will inform this is the gold bond price per gram. Maximum 4 kg one can avail individual. Apply, click here for this link. That will be shared subsequently when you keep searching. Customer requirement is there. If you search there, it will be getting populated through our official social media platform. There, if a customer is interested, he can apply there. Suppose there itself we ourselves will put a, you don't have any account. Yes, click here to open an account. Fully digital. Everything is digital. Just you will have to have the soft copy of your Aadhaar, PAN, and photograph with the digital signature. That also we put it in the white paper just to catch all of it. And then everything will be over. Savings bank account will be open. Subsequently, you can purchase gold bonds also. Wherever, suppose if you are having funds with some ICICI bank or something like that, of course they also sell that product. You can transfer the funds to SBI, and then you can make it purchase this requirement, which is purchase of sovereign gold bond. So that is what I want to convey through the social media platforms, and through this we majority of this thing we want to increase. We want to increase.
So is that what I thought about using their social media activity to offer them some credit card or something offers?
Exactly.
Does that happen?
Yes, exactly. One more thing also which I want to say, because this is a good forum for me to communicate such type of things from the government run institution. I want to access internet here. Is it possible for me to?
Yeah. It's already connected.
These are all new initiatives which we have been taking. I take pride in communicating those things to you. This is our bank's official website. The customer has to go through only this site for whatever information he has got access to here. Now, kindly please look at the right extreme spot below. I am clicking there. You will find ADYA. ADYA stands for automated dose for your assistance. Actually, it is in a very nascent stage only, but since because this forum is good for me to communicate such type of information, I am just informing you. See, suppose here, hi, welcome to Indian Man. I am Adya. How am I to assist you? Account balance, mini statement, checkbook request, start WhatsApp banking, apply loan, online interest certificate, online services, re-KYC, branch ATM, invoices. Okay, I will try a small thing for information purposes, a live thing I will try in front of you. Basic thing, I am trying for a basic thing. Account balance. Immediately it asks, please enter your registered 10-digit mobile number because that is very unique and we trust upon it. So now I am giving my mobile number. Please enter the OTP sent to your registered mobile number.
Mobile number has become public to all of us. Will all disturb.
Now you should not say it's date of birth also invisible. See, suppose if I have a public provident fund account, you see, this balance it is showing. See, this is a very, yeah, that's all, the job is over. The job is over right now. See, just what I want to convey is the requirement of this digital banking or this technology is very much essential in present banking scenario. See, for want of this type of a basic thing, just for suppose if you call from that toll-free number also, you'll be able to get the balance. However, this PPF, these are all people regularly suppose they come in the month of January or February or towards tax saving purpose. That time only they'll be looking at all the things. But for this, an employee who is working in suppose some Infosys or same Tata consultancy service, he cannot afford a leave, he cannot take permission, he need not come to the branch. So in a self-service mode, his time is getting saved and so much information he is able to access through safe and secure method. So this is what which I want to convey. These are all the initiatives, though it is very small and starting level. Such type of initiatives, many things we are taking. Not only our bank, all the government banks, they are initiating such type of things. So thank you for giving me this opportunity. Wholeheartedly, thank you for being in front of you to share all my experience with respect to all these banking services.
Thank you, Satish. So thanks for this wonderful talk, and also thanks for your kind sponsorship for behalf of the organization and technology. So it was a small token of appreciation. Oh. So that means background. The French manager is here. Okay, please come. You also please come.
My other colleague is there, just I want to.
Yeah, this is the main person through whom actually we contacted.
Thank you so much.
Thank you so much, sir. Very welcome. Okay, the final talk will be from Section 8 company ideas, and the history behind these companies that ISI got one TIH from the Department of Science and Technology, Technology Innovation Hub for data analytics, mostly for data analytics, and based on that, these ideas was formed. On behalf of ideas, so this is not a research talk or the company product kind of thing. So the CEO of ideas, he will give the overview of the activities of ideas as well as the opportunities available in ideas. So now I request Mr. Ognimitra Vishwas, CEO of ideas, to present his speech.
Thank you. Thank you, Professor Garai. Good afternoon, all of you, and thanks for staying back for this session. I know we are running late, so I will cut down my time into half. And most of the people in this auditorium, if you are already ISI students, you probably know what ideas is all about. Those who are not from ISI, maybe they are not aware, so I will take them through a quick run through of what we do. So the idea of TIH, as Professor Garai mentioned, that it was formed under mission from initiated by Government of India, Department of Science and Technology, called National Mission for Interdisciplinary Cyber Physical Systems. So that's a long name, but what it essentially covers is all the deep tech areas and all the new technologies that we hear, starting from data science, data analytics, robotics, cobotics, AI, ML, you name it. So there are 25 technology innovation hubs that have been formed all across India. Most of them are in the IITs. And there are a few other hubs like ISI Kolkata. And different hubs are focusing on different technology domains. And some of those domains are listed there. Of course, not all the 25, but some of the domains. So you get an idea that each hub is focusing on one of these domains. And for all the hubs, the mission, the main aim and objective is to make India a leading player in these domains, right? So for ISI, the domain that was chosen is data analytics, data science, data engineering, data curation, so anything to do with data. And therefore, this Technology Innovation Hub was created with this particular name, IDRs. It's a nice acronym that stands for Institute of Data Engineering, Analytics and Science Foundation. So that was formed under ISI. It is a Technology Innovation Hub. It's a Section 8 company. That means it has a separate existence apart from ISI, and we can undertake projects independently instead of going through ISI for every matter, right? So that gives a little bit of a freedom and flexibility in terms of what we do. These are our vision, the areas that we work in. Primarily, we look into translational research, and this need not be research work done in ISI. We have researchers working all over India in various institutes who are working in various technology research areas, broadly under data science, data analytics, data engineering, data curation domain. Our aim and objective is to translate this research work into products that has some usefulness, some marketability, some commercial viability, either to the public or to the government. So it should be a useful product or technology. That's the whole objective of setting up the hub. We also have a deep focus on nurturing startups, and especially, as you know, in Eastern India, there are not the startup ecosystem is still in nascent stage. There are not too many startups coming up. So one of our objectives is to give a fillip to that whole system so that we can get more technology-driven startups, not only from Eastern India, but our main focus is primarily on Eastern India. And finally, we do a lot of skill development, capacity building kind of programs. We do trainings, we run certification courses in data science, data analytics. So kind of a broad spectrum of activities. That is our vision and where we are right now. So this is a quick summary. 25 plus projects are being run. We have already disbursed 7.5 crores in terms of the fund sanctions. From all these projects and researches, there are 50+ publications, 5 patents that have been applied, and we are currently evaluating a lot of potential incubators, more than 20, who would become part of our ecosystem. Some more details about the translational project. So this would be of interest to teachers and researchers, that if you have a research idea where you need funding to convert that research into products, you can approach us. We have completed our cohort 1, cohort 2, and we are launching our cohort 3, which will be launched this month. There are a few other projects. In terms of capacity building, as I said, one of our key thrust areas, we have trained more than 1,200 people and pursuing MOU with government of West Bengal for running workshops on data science, AI, ML across the state of West Bengal. So let's see, the government is showing some interest, so we'll see how it goes. And in collaboration with ISI, we run all of these programs, and we have recently launched our certificate course on data science and business analytics. Some of you might have seen it in your flyer, in your kit. There are also advertisements throughout the campus. But it's not meant for students in campus. I mean, they're already doing this, so it's primarily meant at students or working professional outside the campus. This is our startup. So I will not go through all the details, because I know it's by the end of the day. So some of the application domains that we are focusing on, one core domain that is emerging out from all these researches is video analytics. So we are doing a lot of different kind of researches on video analytics to do different kind of identification of vehicles, monitoring traffic, crowd monitoring, driving conditions, assistance, etc. So these are some. Then the second focus area is, you can say, agriculture ecology related. A number of projects are running in that. We have quite a few projects in healthcare domain, and finally, cybersecurity related research projects are also ongoing. I will not go into the details of these. I mean, you can find all the project links in our website. We have recently started with the help of our technology leader who has just joined, who is sitting right here, Mr. Nithendu. So he's helping us to put together a product that which we are calling as X Insight, explainable visual insights from data. So this is going to be the next level of business dashboards, where you can query all your data in structured and non-structured format through maybe a GPT-like interface. We don't know how the interface will look like, but it is going to be a very, very easy interface to deal with extracting a lot of data and information visually. So how you can engage as a researcher, as a student, or a teacher, or faculty, these are some of the programs that we're running. So of course you can apply for project grants. If you're a student, you can apply for our fellowship grants. So Chanakya Fellowship is our flagship program, where different kinds of fellowships are available to different levels of students, undergraduate, postgraduate, postdoctoral, at all levels. There are different kind of fellowships. We are actively looking for applications in these areas. So more details are available in our website, but that's something that you can, you should aim at. We are open to industry consultancy, and we are working with a few potential clients to see what kind of industry problems we can solve at our institute. And finally, we are also partnering with many, many institutions for mentoring and give backs. I mean, there are people out in the market who want to partner with us. Maybe they can guide startups, they can guide our product development life cycle, and many others. And if you are interested in becoming a mentor, with ideas TIH, please approach us. The incubation program, this is aimed at the startup. So some more details about the incubation program is also. I will not go through the details, but right now our cohort 2 incubation startup evaluation is ongoing. Once those are completed, we'll go for the cohort 3. You can get funding as much as 50 lakhs of rupees for your startup idea to mature from from prototype to a product level, and along with assistance and guidance, etc. We are also ready with our infrastructure for incubation. And this is just a snapshot of the incubation and innovation conclave that we had in October, attended by so many different participants and representatives from the industry. And finally, this is the course, the certification course that we have just launched, and which is starting from January. So if you have within your friends and family network people who might be interested, it is open for all. Kindly communicate this information to them. All the information. So this is going to be a 3-month long online program with 1 week of immersion program in ISI, and this is curated by ISI faculty, and also a major portion will be taught by ISI faculty as well as industry experts and our own experts. There will be a lot of hands-ons and a lot of case-based learning. So a very good opportunity for both students and working professionals. So with this, I come to the last slide, and this is where our website link is given. So those who are taking screenshots, please visit our website, and you can find all the information that you need about the details of the training certification program. So please note the website. I think that should be good enough. www.ideas-tih.org, or you can write to me directly at ceo@ideas-tih.org. Thank you very much. Thanks for your patience hearing.
Very nice coverage. That shows the activities, opportunities available with ideas. So you must have some queries, right, from students or potential startup owners. Jovin, you have any query that?
It's more of a general question. How is the startup climate here in the campus? Do you see a lot of students venturing after their courses?
Not really, and that's one of the areas where we want to work. So what is planned immediately after this? Maybe after December, we'll run a in-campus hackathon. So first, we have to shake up the student community here. Yes, we are planning a bigger hackathon also, but first we want to start with the campus one. We already did a couple of sessions within the campus. There were students who came up and inquired about it, but yeah, it's a long way to go.
Thank you.
Any more queries? If not, then let's thank Mr. Vishwas once again for their kind sponsorship from that Ideas company, and also thank you for coming here.
Thank you for the
opportunity. So on behalf of the organization, I have a small token of appreciation from Mr. Vishwas.
Thank you.
So with this, now we conclude that this particular session, industry session. Now, on behalf of the organizers, do you have an announcement right now? Okay. Thank you all.
thanking Professor Rai for conducting the session. I would request Professor Roger Kumar of Indian Statistical Institute to please come on stage and felicitate Professor Rai with the medal.
পিএনসির সঙ্গে ছবি তুলবো পিএনসির সঙ্গে ছবি তুলবো থ্যাংক ইউ ও গ্রেট ব্যাগ আছে ব্যাগ দিয়ে দাও এক্সেলেন্ট
Next, we have Professor C. Murthy Memorial Colloquium for doctoral candidates. I'll request Dr. Tormoy Bushu of Faisal Gopal to please come on stage and share the session. Thank you.